Thank you. Yes, total differential. I'll add this to the playlist with more practice exercises. What matters to me now is the formula. Specifically, the total differential for a function is given by the sum from I equals 1 to n of the partial derivative of f with respect to xi times dxi. What does that look like in an example? Don't let xi confuse you. xi. It now depends on what you write. You either have a function fx or fxy. I'll take as an example x to the power of x cubed plus y, or you write accordingly fx1, x2, and then accordingly x1 to the power of x minus 1 cubed plus xx2. And that's something you really need to understand. And the total differential now results accordingly from the sum. And the sum then results from taking the partial derivative with respect to each of the individual variables. Times, and that's this small change, then along xy, xyz, or x1, x2, x3, x4. Let's take an example for this. For this, d/df would now be equal to, namely the partial derivative of f with respect to xd dx plus the partial derivative of f with respect to yd dy. And here, accordingly, it would be the total differential. The partial derivative of f with respect to x1 dx1 dx1 plus the partial derivative of f with respect to x2 dx2 dx2. What you definitely need are the partial derivatives. Yes, that means we have the partial derivative with respect to x here, which is 3x squared dx plus. The partial derivative with respect to y is 1 dies, so here accordingly df equals the partial derivative with respect to x. Sub 1 is 3x sub 1 to the power of 2 dx sub 1 plus 1 dx sub 2 y. Now you can also choose another point accordingly and then think about what actually happens. I also have corresponding examples in the playlist. For example, if you take the point P, P1 and 2, then the total differential looks like this. Yes, what happens if you move minimally in this case with respect to x and y, or x1, x1, x2? How does the function value change completely here as a result? That means you would first substitute into the original function and then you make a change. For example, let's say ddx would be 0.01 and ddi would be 0.01. The smaller, of course, the better, and then you see what result you get. If you now add these small function changes here and substitute them in, or if you substitute them into the total differential here, watch example videos about this. And here, as I said, you need to understand from I equals 1 to n. For example, if you now take a function with 3 arguments, x1, x2, x3, then you would have, for example, d. df is equal to the partial derivative of f with respect to x, partial x1, x2. x2 dx2 plus partial derivative of f with respect to x3 dx3 dx3, and so on accordingly. Math term recognized, danger averted.